Hello, everyone, and welcome to Part B of Section 3.6 in Algebra 2, Quadratic Inequalities. We're starting off on page 26, where we have our word problem. It says, accident investigators use the formula D is equal to 0.01875 v squared, where D is the braking distance of a car in feet and V is the speed of the car in miles per hour, to determine how fast a car is going at the time of an accident. For what speeds v would a car leave a tire mark on the road of over 1 foot? So let's start by writing down our equation. D is equal to 0.01875 v squared. So in other words, if they know the velocity of the car, they can square it, multiply by this number, and tell you how long it's going to take for it to break. However, the accident investigators are doing it backwards. They're looking at the distance that it took to break by looking at the tire mark on the road, and then they're going backwards to figure out the velocity. So we want to know what velocity would create this distance to be greater than 1 foot. So we want this distance, which is equal to this 0.01875 v squared, to be greater than 1. So our first step is going to be to divide both sides by 0.01875. 0.01875. And when we do that, we get, sorry, I have to do it on my calculator. This is definitely not math I can do in my head. 53.3 repeating. I can tell I was still looking at my calculator. 53.3 repeating. And remember that our goal is always just to solve it with an equal to sign. So I'm going to do plus or minus the square root of 53.3 repeating, square root, and I get V is equal to plus or minus 7.303. I'm going to make my little chart here, negative 7.303 and positive 7.303. Now, even though this is an unusual number, all you have to do is plug in a number that is greater. So you can pick a number like 10. So if I pick a number like 10 and I square it, I get 100, and 100 times 0.1875 is 1.187, which is greater than 1. So this is definitely going to be where the answer lies. If you try a number like 0, obviously this number times 0 squared is not greater than 1. Now, you could technically say that this is also going to produce an answer, but now we're doing a word problem. So it's your job to think about the domain. Domain is all the things x can be, or in this case, all the things that v can be. Well, it's going to have a positive speed. So v is greater than or equal to 0. So I'm actually not going to consider this as part of the answer. So if the velocity is greater than 7.303 miles per hour, then it's going to leave a tire mark on the road of greater than 1 foot. Back to graphing. You're not going to escape it. If you don't like graphing, it's going to keep coming up all year long. So we get to practice 6 graphs. And what's going to be interesting about these is we're doing 2 on each one. And a system of equations is normally where something intersects. So this would be the solution to the system of this parabola in this line. But now all of a sudden, we're going to have a whole shaded region and another whole shaded region. And now the answer is going to be its own shaded region. This is where the blue and the yellow intersect. We'll actually do it, and then you'll see. So remember, how do we solve a quadratic inequality? How do we graph a quadratic inequality? I change it to an equal sign so that I can just make the graph. This is just a downward parabola, 0, 0, 1, 1, 2, 4. It's a solid line. I can't test the point 0, 0. So I'm going to have to test a different point. I'm just going to test, I don't know, 0, 2. So I'm going to test 0, 2. When I put a 2 in for y, is that greater than or equal to negative 0? It is greater. So I do want to shade that whole region. Now here's the problem. If I shade too heavily, then it's going to be hard to shade two different things at the same time. So I'm actually just going to shade a little bit above instead of the entire region. That way I know, yeah, I want to shade up there, but I'm not going to shade the whole thing right now. It'll make it a little too cluttered. Now I'm going to graph my other one. Y is equal to x squared minus 2. This is an upward parabola that's been moved down 2, but it also goes through 0, 0, 1, 1, 2, 4. There's no A. So 0, 0, 1, 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. This little point was the one I was testing. It's not part of my parabola. And on this one, I can test 0, 0. So 0 is greater than 0 minus 2. 0 is greater than negative 2. So I do want to shade 0, 0. So I want to shade inside this parabola. So inside this parabola. So now the question is, what is the answer? If I shade inside this parabola and outside that parabola, what region am I getting? It's a little hard to figure out. It's this one right here. Can you see that? It is not there, and it is not these regions at all. It is just that region. Maybe I'll add this color just so you can really see it. It's this region right here. Okay? If you want to go back and kind of get rid of the other colors just so you can see the region more clearly, that's up to you. But I don't really need you to do that. Especially if you're going to make a mess of it like I did. All right, there's your region. Very colorful. All right, we get to practice graphing our parabolas again. This one is in intercept form. It has an intercept at 4 and 2, which means its axis of symmetry is right at 3. So now I know that 3 comma something is going to be the vertex. So 3 minus 1 is 1, and 3 minus 4 is negative 1. So that makes negative 1. 3, negative 1. It is an upward parabola. If I were to multiply it out, which I'm not going to do, but its A would be 1. So I can use 0, 0, 1, 1, 2, 1, 2, 3, 4. Zero, 0 is available to test. When I test 0, 0, so I'm going to test 0, 0, I get 0 minus 2 times 0 minus 4 is positive 8. Is 0 less than 8? It is. So I want to shade 0, 0. So I'm going to be shading this side of the parabola. I would shade the entire thing, but it's going to be really hard to see in the end. So I'm not going to do that. Okay. My other one is a favorite because the vertex is right there for you. It's at 2, negative 4. So 2, 1, 2, 3, 4. It is also an upward parabola and also has an A of 1. So here's my 0, 0, 1, 1, 2, 1, 2, 3, 4, 2, 4. It looks something like this. 0, 0 is not available to test because it actually goes through 0, 0. Oh, and I just realized it's dashed. So I have a cool little dashing tool. I feel compelled to use it. But you can just use your eraser and make your line that you drew dashed. So I'm going to have to check a different point. You can check whatever point you want to. I'm going to check, let's do a really far one out there. I'm going to check 0, -5. So is 0 greater than -5 minus 2 squared minus 4? That's -7 squared is some big positive number. Minus 4 is definitely going to be a big positive number. It is not going to be greater than 0. Notice you don't need to actually finish it. So I don't want to shade this area. I want to shade inside this parabola. Now, if I shade inside this one, but outside that one, here's the region that I end up with, but not that region over there. That came from doing outside the other one. Okay, a little bit tricky there, but you're trying to get just that one region. Okay, last graph. So the top one is just the way we like it. It is in vertex form. The vertex is -4, -2, -4, -2, and the A is just 1. So from my fake 0, 0, I can do 1, 1, 2, 4 in the other direction, 1, 1, 2, 4. I am going to have to make it dashed. So it looks like this. And for the last time, am I going to shade inside or out? Since it's 0, 0, I plug that in. 0 is less than, if I put a 0 in here, I get 16, not less than. 0 is greater than 16 minus 2, which it is not greater. So I don't want to shade 0, 0. 0, 0 is not a solution that works in this inequality. So I don't want to shade it. So another choice instead of shading is sometimes I just go like that. Just enough to remind me that I want to go on this side without actually shading. And then my other one, okay, so we've had all these equations. This is the first one that we've had to use -b over 2a for. It's not people's favorite, but when it's written in standard form like that, it's your only choice, unless you can factor it and change it to intercept form. So I have -1. Now I'm going to do f of -1, which is -1 squared plus 2 times -1 plus 2, which gives me 1. -1, 1. This is also an upward parabola with an a equal to 1. So from my fake 0, 0 there, I'm going to go 1, 1, 2, 4. I'm going to do the same thing on the other side. 1, 1, and 2, 1, 2, 3, 4. It's solid because it's less than or equal to. And it's so easy to test 0, 0. 0 is less than or equal to 0 squared plus 2 times 0 plus 2. I don't even expect you to write this out because this whole thing is going to be 0. Is 0 less than 2? It is. So I do want to shade 0, 0. So that means I want to shade outside this parabola. So now kind of look at the two little marks that I made. What part shades outside the green but inside the blue? This part right here. So some people have a little trouble getting the hang of this. I don't know if this helped more doing these little, half shading things. But there's your final answer. The next problem is actually number 16 from the book. The first time I read it, not that one. This one is number 16 from the book. The first time I read it, I didn't really know what they were looking for. I overthought it, so I thought I'd put it in the notes so you don't overthink it. It says, use the graph to write an inequality in terms of f of x, so point P is a solution. So in order for point P to be a solution, what they're really saying is write an inequality that would shade this portion of it. And like I said, I thought I was supposed to actually think of the graph, and I'm thinking they didn't give me enough points or anything. They're literally looking for y is greater than or equal to f of x. So whatever f of x is, if y is greater than it, then it's going to end up shading the upper portion. So don't overthink that too much. Okay, we have 2 word problems to do. The first one says, a rectangular fountain display has a perimeter of 400 feet. Actually, it said rectangular. I drew it as a square, so I don't always make my drawings perfectly accurate, but we can improve on them a little bit. So let's call this x and y. Its perimeter is 400. And perimeter is always determined by adding up all the sides. So x plus y plus x plus y, if I go all the way around. In other words, 400 is 2x plus 2y. The biggest mistake I see in perimeter is people just saying x plus y, but it's 2 x's and 2 y's. Now it says it has an area, which for this shape is x times y, just 1, not 2 this time, just this distance times this distance will give you the area. And they want this area to be at least, that means greater than or equal to 9,100. So x times y needs to be greater than 9,100. So let's say that y is the one that's the width. This formula is in terms of x and y. They want something that just describes the widths. So I can use this equation so you can express xy just as y. Watch how we'll do that. 400 minus 2x is equal to 2y. Oop, I think I'm going to do that. I need to do it backwards. I need to do minus 2y is equal to 2x. Divide by 2, divide by 2, divide by 2. 200 minus y is equal to x. So now watch what I'm going to do. I'm going to replace the x with 200 minus y. See why it was important that I solved it for x, so I could get rid of the x. For some reason, that is never intuitive to me. Is greater than 9,100. 200y minus y squared is greater than 9,100. Is this something that we can solve? Absolutely. We temporarily pretend it's an equal to sign, and then I'm actually going to solve it. I see a y squared in my equation. What do? I set it equal to 0, and I factor. So I put the y squared on the other side and the 200 on the other side, and I leave the 9,100 over there. And what do we do if we can't factor? I mean, it's possible that 9,100 can be factored, but if you don't want to sit there and spend the time trying, you can always use the quadratic formula. But you know what we haven't done in a while? We haven't done completing the square. When this is 1 and this is even, I have to tell you, I think that this is just a little bit faster. So I divide this number in half. I write down my square, and then I actually square this. So when you square something with zeros, it doubles the number of zeros. So this is going to add 1, 0, 0, 0, 0. It's going to add 10,000. But simultaneously, I want to subtract 10,000. So 10,000 and 9,100 give us minus 900. I think that was faster than quadratic formula. Now, to finish solving it, I can do 900 is equal to y minus 100 squared. I square root both sides. The square root of 900 is 30 is equal to y minus 100, plus or minus. I add 100 to both sides, and 100 plus the 30 is 130, and 100 minus the 30 is 70. So I've found my two answers. If you looked at that and said, oh yeah, I know we did that earlier in the chapter, but I can't stand it, that's fine. You don't have to use completing the square. I just wanted to show you when I think it's easier, because I didn't want to try and factor 90, 100. It turns out that the two factors are 130 and 70, but I wouldn't have thought of that. So here's my 70, and here's my 130. If I plug in a number like 200, then is 200 going to make this greater than or equal, keeping the sign? So it's actually probably just as easy to do in here. 200 minus 100 squared minus 900 is going to be positive, which is not going to be greater than 0. But if you try a number like 80, then 80 minus 100 is negative 20 squared, which is 400 minus 900, which is going to be negative, which is less than 0. And if we try a number over here, it's going to come out to be positive. So the answers that work are the ones between 70 and 130. What does that mean for us? That means that we would like our width should be between 70 and 130. Make sure you put your units on there. It's feet. So sometimes people get confused because they say, you want it to be negative? I don't want it to be negative. I want this equation to be true. The question is, what makes this equation true? And it's true if y is any number between 70 and 130, because that would make this less than 0, which would make this equation true. So we're kind of putting it all together now. So for this last problem, I could do it by hand, but I'm always trying to teach you more about your calculator. So I'm actually going to switch to the calculator and show you how you can do it on there. So what I'm about to show you is a fantastic way to solve a quadratic equation using your graphing calculator. So I've already typed this in, but where you're going to put it, hopefully you're actually doing this on your own so you can make sure you understand it, is I'm going to go to the button that's y is equal to, which is now in red. And I've already typed the two halves of the equation in. You don't even have to set it equal to 0. You can literally type in the first half of the equation as y1 and the second half of the equation as y2. Then you would hit graph. Now, unfortunately, I can't see the two halves of the equation. So this is the one reason why sometimes people would rather do it by hand, because they don't want to be bothered with the window. But it's such a great method. It's worth learning how to use the window. So I go back to window, and I could see that it was going up. So let's just say it might go all the way over to 30. Let's hope it comes back down by 30. Now, I know since y2 is equal to 11, I need to get to at least 11. So let's go to, let's say, 15. All right, now let's hit graph. Now I can see it. So the two answers to this quadratic equation are literally the points of intersection. So I'm going to go second, calculate, and then I'm going to go down to number 5, intersect. It's always going to ask you 3 questions. What is the first curve? And it's going to highlight it, but it's also going to write it at the top, y1. So you hit enter, and then it's going to go to the other ones because is this your second curve? And you say yes by just hitting enter. And then it asks if you'd like to make a guess. I don't usually guess, so I just hit enter. And there you go. One of the places where this equation would be equal to 11 is if x is equal to 14. Now I need to know the other one. Remember, there's always 2 answers to a quadratic equation. That comes from the plus or minus the square root of b squared minus 4ac. Always 2 answers. Second, calculate. intersect, first curve, enter, second curve, enter. But now you do have to change your guess. You're going to have to either use the arrow key or a physical guess to change it. Otherwise, it's just going to give you the exact same guess. Oops, I accidentally hit something. Second, calculate, 5. First curve, second curve. Okay, so if my guess, as long as you're a little closer to this one, it's going to find that one. And there it is. The answer is 6. Isn't that a fantastic way to do that? All right, back to our problem. So what we did on the calculator, just to say it one more time, is very cool. You had a quadratic equation, and I've been saying over and over again, whenever you see an x squared in an equation, what do? I would love for you to set it equal to 0 and factor. That will 9 times out of 10 be the fastest way. But you have 3 other methods. One is completing the square, which is not convenient if this is not 1 and this is not even. You have quadratic formula, which is fine, but still pretty difficult. And then we had the graph, where we actually made our calculator graph it, and then we also graphed the 11, and we figured out what the 2 answers were. And they were 6 and 14. So when x is 6 and when x is 14, that's where you got a height of 11. So what does this mean for a truck? Well, a truck is not a skinny single point. A truck is a whole entire big boxy thing with wheels. So if this truck is going underneath this bridge, it has to be between the 6 and the 14 or it's going to hit the bridge. So what is the distance between 6 and 14? 8. So the maximum width that a truck can be is 8 feet wide. This problem is very challenging just to understand what the 2 answers mean in the quadratic equation. So if the truck will hit the arch if x is 6 or if x is 14. So how wide can the truck be? It can fill up that entire distance of 8. All right, last one. What is the maximum height that a truck 7 feet wide? So does it make sense? I'm just going to erase this picture here. So now, does it make sense that if you don't have an 8-foot wide truck, you only have a 7-foot wide truck? It could actually go just a little bit higher, right? Because if when it's 8 feet wide, it can only go 11 feet high, this is going to be able to go just a little bit higher. Their question is, how high can it go if it's 7 feet wide? So just like the 8 feet was the span between the 6 and the 14, the 7 feet must be the span between 2 numbers. So the real question you have to ask yourself is, what is the vertex? Well, based on the 6 and the 14, the vertex was at 10 comma something. Doesn't actually matter what it is. So if you have a 7-foot truck, then if 10 is the vertex and your truck is 7 feet wide, that's 3.5 on either side if he goes right down the middle. So that means now you're looking at 13.5 or 6.5. So I want to know the height at 13.5, f of 13.5. And it should come out exactly the same as f of 6.5. So it's not that I don't think you can't plug it in by hand, but of course, I'm just wanting to show you all the cool things that your calculator does. So remember, we already have this function on our calculator. So what you can do is you can do second calculate. You're going to use this feature a lot. Last time we used it for intersect. Now we're just going to use it for value. Number 1, I want to know the value when x is equal to 6.5. And watch this. You just hit enter, and it's going to tell me the value. When at 6.5, it's going to be 11.234375, but you can just round to the nearest thousandth in general. And remember, It also should give us the exact same answer if we go to 13.5. Let's just check that. Second, calculate value when x is 13.5. Hit enter, and there you go. It's the exact same number. So there's a really great way to do it on your calculator. And that concludes chapter 3. I just wanted to say that I realize we have just finished a super hard chapter, the longest chapter, twice as long as any chapter we've done so far. And you guys are working so hard. Thank you for the great job you're doing, and keep up the good work. I'm really, really proud of you.